Good morning, class. This is very early for me, but I thought I would try to record early, and then if I need to post it, hopefully I can post from home. Anyway, good morning. And hopefully it's not 6 o'clock where you are right now. That would be painful. So, okay, we're going to 7.1 scale factors. So turn in your books to page 243. And the first thing, this is all a unit on shape and space. So we've done surface area. Now we're going to do some scale factor, one of those similar shapes and things. So first thing we're going to talk about is what polygons are. Poly means many, right? We've determined that polynomials means many terms, can be any number of terms. So polygon is just a generic term for any shape, basically, that's enclosed. So a polygon is the union of three or more segments such that each segment intersects exactly two others, one at each of its endpoints. So basically the shapes you've all heard about. Triangles, three different types there, lots of different types of quadrilaterals. And of course, then we get to pentagon, hexagon, etc. down the side. So what is interesting to note is how this quadrilateral section stands up. So there are some special ones. I think what most people don't realize is that under a parallelogram, I think we all kind of know what a parallelogram looks like. We can imagine it. A rectangle is actually a parallelogram that has 90 degrees in the corners. And then a square is a type of rectangle that has not only 90 degrees in the corners, but it has all sides the same. So that's kind of a little tidbit that most people don't think about a square actually being a type of a rectangle. All right, so there's some review on triangles. 3 sides. Some of the angles always add to 180. That's some little info that just to remind you. Angles on a triangle always add to 180. There are 3 types. We have the equilateral, isosceles, and scalene drawn for you. Equilateral, all the sides are the same. Isosceles, 2 sides are the same. And then scalene, none. Now, what goes with the side lengths are the angle lengths. If 3 sides are the same in an equilateral, then you have 3 angles being the same. All 3 of those angles will be the same size. And in an isosceles triangle, if you have these 2 sides being equal, then the angles opposite those in the corners are also equal. So that's an important thing to note about an isosceles triangle. And scalene triangles, of course, no equal sides, no equal angles. All right, quadrilaterals, 4 sides. A 4-sided polygon, no matter what the shape it has, if all 4 sides connect, it's going to have 360 degrees. So there's just some shapes for you to see and some definitions. Rhombus is kind of a fun shape. It has 4 equal sides, but they are not 90 degrees in the corners. That would be a square. But anyway, and then we have some rectangles and squares. And then, of course, there's your kite. A kite has these pairs of sides that have the same length. It says consecutive sides the same length. So the ones that are 2 of these touching, you can see there's 2 different kinds of kites that you could have. All right. What makes something similar? If you were asked to make a drawing of a polygon or any figure, you might make the drawing larger, smaller, or the same size. But if you want the figures to actually look alike, the shape must be the same, and the corresponding lengths have to be proportional. So you can imagine that just when you expand something and blow it up. Our cameras now have the ability to distort pictures, not just enlarge them, which creates some crazy looking things. Thankfully, I don't know if there's any of me out there on the internet, but my kids sometimes like to take pictures and distort them. You've all seen those. Those are distorted. They're not proportional. And so, yeah. Anyway, 2 figures are similar if there's 2 things. Take note right here. Big deal. Corresponding angles have to be the same, and the lengths have to be proportional for them to actually be similar. And we use this little symbol, kind of just a little squiggle, to show similar figures. So we can talk about that in a minute when we go to do our homework, but just keep note of the 2 things that makes them be similar. So they have to have the same angles, the corresponding angles. So I kind of put my hands together. If you could see me, I would put my hands together and say the angle between my thumb and my pointer finger, they're the same angle. So maybe that's not a good example, but mostly I guess people's hands are similar to each other because usually they're proportionate to the size. Okay, scale factor. Figures that have the same shape but different sizes are found throughout everyday life. Maps, architects' drawings, models of atoms, model trains are some examples of similar figures. When you compare a model train to the real train, the model is much smaller. It's called a reduction. And when you compare the drawing of an atom in your science text to the actual atom, the drawing is much larger. That's called an enlargement. And here is the ticket. You can find the scale factor by taking the image length dividing by the object length. I simplify this and say the scale factor is the picture over the real. But image over object, picture over real, you always, that will help you find the scale factor. Now, we have to remember what the scale factor is. The word factor means what we're going to multiply by, right? When you see that word, you should be thinking about multiplying. So if I told you the scale factor of something, you would have to multiply that scale factor to use it. You can find the scale factor by taking the length of the picture or the image that you've created and dividing it by what it once was, or by its original, by the real, or by the actual object. Picture over real. If the image is larger than the object, then you have an enlargement. If it's smaller, you have a reduction. And of course, if the scale factor was just a 1, you multiplied everything by 1, it would be the same. The image and the object would be the same. There's some ways to do this. This is kind of some neat things that I've seen in this book I've never seen anywhere else, and that is to pick a point and then draw these lines from that center point P to the corresponding B and B prime. So I do want you to note that in this textbook and in most textbooks, when you see a C with a little apostrophe on it, that means, I call it C prime, and it means what you have created. It's now the new picture. So this point C corresponds to C prime. So when you're talking about something being created from something or something being new, you always want to look for the C prime. That's the new object or the new picture of the original. Okay, so you can do that, and then you can measure these lines, and they should be proportionate. This method 1, I don't think we'll use it much. You would measure how far it was from P to A, and then measure how far it was from P to A prime, and those proportions should all be equal. The other thing to do is simply go and measure. I'm going to erase all my lines here. To actually go and measure and compare the two objects. So you can measure this line from A prime to B prime. And then if you went and measured this A to B, whatever those numbers were, they should be the same if you measured from B prime to C prime in correlation with B to C. So that's what we're seeing here. The proportion of the two fractions should be the same, and that will be scale factor. So if we were to actually go and measure them, I'm just going to show you method 2. If you were to actually take your ruler and go measure A prime to B prime, you would find it was 2.4, and A to B is 1 centimeter. That gives you your scale factor of 2.4. So given any other side of the original, I could multiply it by 2.4, and that would tell you the new size on your image. I'll say that one more time. Knowing your scale factor allows you to take any measurement off of the original and multiply it by your factor to get the length of the new side. Now, this says, notice that the scale factors from the two methods are slightly different. This is due to inaccuracy of measurements. So we have to give a little bit of room for when we use our ruler to measure. Sometimes we're not exactly perfect, but they should be very close. So in example 2 here, you would need to actually first decide if these two shapes are actually similar to each other, or is one an enlargement. And notice this is the object, so this is the original, and this is the new picture. So if I was going to find the scale factor, I would take the new over the old, or the picture over the real, or the image over the object, however you want to think about it. You always want to make sure you go in that order to find scale factor. Scale factor would be the image over the object. All right, so the first thing I would do is you need to decide before you can do this if these are actually similar. So to be similar, we need to see if the angles are all the same. Now, they don't give you this 80 over here in this angle, but is it true? And the answer is yes, it is. If you were to add up in this object or the image over here, the 105, the 90, and the 85, and then you need to make that 360, you would decide that this was 80. And similarly on the first one over here, if you were to add up those angles, subtract from 360, you would find this to be 105. So that has to be true. For two objects to be similar, the corresponding angles have to be equal. So once we've determined that, it says, why is the quadrilateral ABCD similar to the quadrilateral EFGH? So I just answered that for you. We measured the angles and we discovered that all the corresponding angles of the quadrilateral are equal. And then the next part B, it says determine the scale factor. So to determine the scale factor, you would actually have to get your ruler out and do some measurement. So they've done it for us. We can just use theirs. The scale factor is always the image over the object. So they measured EF and found it to be 3.0. Then they measured AD and found it to be 3.8. And you do that division and you get your scale factor to be 0.8. So part C says, if AD in the original object is 4, right here is where I'm reading. If AD is 4, determine EF. So all you have to do is take your 4 and multiply it by your scale factor. So they take 4 times 0.8 and get 3.2. Scale factors are multiplied. I cannot stress that enough to you, that factors are what we multiply by. Okay, here we go. Question 3, they put this, their original and their image on a grid and gave you the points that they meet at. Now pay attention here. Do you see the primes? This triangle down here is the one that has A prime, B prime, C prime on it. So that is the new. This is the original. So we have to keep track of what we're doing here. So we're going to go from a larger triangle down to a smaller triangle. Because they put this on a grid for you, it's easy to see what happens. The point 10 and 8 up here, point A, 10 and 8 becomes 5 and 4. So we can quickly say, oh, we're making it half as big. Just be sure. Check all your points quickly. Do a quick reference. 14 and 6, yeah, becoming 7, 3. Indeed, all of the points are half the size. So we know that the scale factor is 0.5. Because we would multiply the original by 0.5 to get to the new picture, A prime. 10 would be multiplied by 0.5. So don't think of it as a 2. Think about what do you have to multiply the original by to get the new image. Okay, basically, we're ready to roll. I just want to remind you down here on questions 2 and 3 that you would need to, if you just want to use your formula, it works every time. Scale factor is equal to the image over object, or the new over the original, or picture over the real. So when we get something complicated, so some of them are easy, but when you get down here to these questions down here, some kids might have troubles with that. I'm literally going to put my 1.5 into where the scale factor is. I'm going to put my image at 48, and the object is what you don't know. So if you set up that proportion like that, you can put this over 1 and change colors so you can see what I'm doing. You can put that over 1, and now you can actually cross multiply. So if you don't have a clue on earth what to do, you can go cross multiply because we have 2 fractions with an equal sign between. So I'm going to put this equal sign down first, 48 on one side, because I'm going to go 48 times 1, just reminding you how to do this in case you're forgetting. And this way, I'm going to put 1.5 times x. At this moment, I'm going to divide 48 by 1.5, and I get 32. So that is my object length. So that is an example of how to fill out these tables. You can start with your formula, plug into your formula, and then cross multiply and solve. Should work every time. I can show you one more example down here. Maybe I'll change colors again. Let's do this question right here. So I would say my scale factor is 0.6. My image, I don't know. My object is 14.7. Put this over 1. Go ahead and cross multiply. This is the easy kind because it's just straight in. So I'm going to go 0.6 times 14.7 and get 8.82. All right. So do your homework. Looks like you should be okay. I can maybe show you how to do one of these questions down here on 5 and 6, so you can see it. What they expect you to do on these questions is they expect you to measure with your ruler. You will need a ruler. They expect you to measure from this point, maybe. Oh, I'm loading. They expect you to measure from the point to the baseball, and then they want you to go, in this case, it's half as far. So they want you to go, if that was however many centimeters that was, you would cut it in half and put a mark at the top, which is where you would start your baseball. So it would be somewhere around this area, right? Because you would measure how far it was from this point to this point. And then you would, if that was 6 centimeters, for example, then you would start this at 3, and that would be the top of your baseball. And the same thing on the bottom. You could measure how far it was from the point to the baseball, and halfway in between is where you would put that same corresponding point. Similarly with the football, I don't know what's going on here, but with the football, you would, however far it was from the point to the top of the football, however far that was, you would multiply it by 1.5, and you would measure from the point out there 1.5, and that would be the tip of your football, etc. So hopefully it helps. You can join me on our Google Meet if we want to talk about how to do those questions. All right. Good luck. We'll put the assignment up on Google Classroom.